So in this problem, we want to find a value of m, if possible, for which f prime of 3 exists. So f of x is a piecewise function. It's defined by y equals 4x squared if x is greater than or equal to 3, which is differentiable everywhere. Its derivative exists everywhere. And it's defined by y equals mx minus 36. That's some line with y-intercept negative 36 and slope m if x is less than 3, which lines are differentiable everywhere. So we need to find the value of m so that f prime of 3 exists, because at 3 is where the break is made between the two sides of this piecewise function. So let's go ahead and do a quick sketch of the right side. Part where x is greater than 3. Okay, so I'm going to plug in some numbers over here. So f of 3, let's find that, will be 4 times 3 squared, so 36, and it's only going to get bigger. So I'm going to go by like tens here. Because if I plug in 4, it's probably going to be astronomical. Let's see, 4 times 16 is, 64. Okay, so when x is 3, the y equals 4x squared. Yeah, let's graph this in purple. Okay, is, what did I say, 36, it's right about in there. And then when x is 4, it's a parabola, and it's just going up. The curve on this parabola, the vertex would be at 0, so it's just going up. So 4, 64. Okay. So what we need to find is the slope of, or the derivative of, y equals 4x squared. Like, we need to find the slope of the tangent line right there, because we want the slope of the tangent line at 3 on this parabola's graph to equal the slope of this line over here, so that it's differentiable everywhere. Okay, so for y equals 4x squared, its derivative would be 8x, but I'm really just interested in its derivative at 3, right there. What is the slope of that tangent line? So 8 times 3 is 24. So that's what I want, the slope of the line, because the line, let's see, is mx minus 36. So it's going to connect, hopefully this is possible. It's going to connect down here at negative 36. Now, I'm given a lot of information in this problem. I mean, it would have been possible for them to say, find the equation of the line mx plus b so that it's differentiable. But they didn't. They only are letting me choose m. So we're hoping that the slope of the line that goes through, because it also has to be continuous. The graph has to be continuous everywhere. So the slope of the line that goes through 0, negative 36, and this point, 3, positive 36. Hopefully the slope of that line is 24, so that the slope of the pink line equals the slope of the quadratic. I didn't draw my graph very well, but they're supposed to have the same slope so that it's smooth and continuous right here at 336. So let's see, the slope of, let's just calculate what is the slope of this line. I know its y-intercept is negative 36 from that, and for it to be continuous, it's got to meet up with the parabola here at 3, 36. So the slope of this line, just using these 2 points, would be y2, I'll use that for my, no, I'll use that for my y2, 36 minus negative 36 over 3 minus 0, that's 72 divided by 3, which is 24 right here. So it does work out that, okay, given this y-intercept, that the slope of this line should be 24. So let's go over here. Yeah, it's not going to exist for any chosen value of m because otherwise the slopes wouldn't be consistent at that point 3. Okay, hopefully that helps on that problem. That is a tough problem. If you have any more questions about it, please do ask.